We're on page 16. We good?
I have it. It's at home.
Is this letter E? Does anyone know what E's value is?
Negative root 1. Oh, that's I.
I is root that's a good point. I is root -1. Pi is
Is it
3.14, and you don't need to write this down. E
natural log?
it has to do with natural log. 2.718 would be a great amount to memorize. And you might be like, what the heck is E even about? You guys, E is named after this dude named Euler. And it's all about exponential growth and decay. Euler came up with this number, 2.718, that has to do with exponential growth and decay. Let me show you on your calculator real fast. Everybody on your calculator, do second divide, enter. Did we all get 2.7182818225? 285?
Yeah.
Okay. So for Pi Day, when do we like to celebrate Pi Day if I don't forget about it? Pi Day is March 14th, 3.14, right? 3.14. When would E Day be? February 7th. February 7th would be E Day.
71st.
Okay, so where the heck does E come from? Check this out. E is just 1 plus 1 over 1 plus 1 over 2 times 1 and 1 over 3 times 2 times 1 and 1 over 4 times 3 times 2 times 1. Do we have to write it like that every time? Does anyone remember what that's called? It's a factorial. So we could say plus 1 over 5 factorial, etc. This is why 2.718 E, it's an irrational number. It goes on forever because it follows this trend. You guys, let's practice typing that in our calculator. Did I mess up, bud?
Oh, enough.
No? Okay. You guys, I want you to go type in 1 plus 1 over 1 plus 1 over, you could do 2 times 1, or you could just do 2 factorial. And I just want to make sure that I show you where that factorial is. Anyone know?
It's like math probability.
Math. On the top, you got a right arrow, right arrow, right arrow into probability. Anyone see that exclamation point? It's option 4. Good. Plus, then we're going to say 1 over 3 factorial. And maybe it's not faster to go all the way to get the exclamation point. And you just want to do 1 over and then just type it out. I'm good with whatever.
What's up, everybody?
Whoa. I did it all the way to 1 plus 1 over 5 factorial. Is that perfect E? Now it says 2.716. You guys, do you think the more factorials that we add to that, the more accurate we're going to get? Yep. Yeah, buddy. So if I do 1 over 6 factorial, is that going to get me more accurate? Yeah, if I were to add on to that 1 over 7 factorial. This is E, though. This is where it all comes from, which who would have thunk? Who would have thunk? We're getting more and more accurate. Okay, so we are going to note that E is an irrational number. It's a decimal. We cannot represent it as a fraction. It goes on forever. If you were to remember E is 2.7, I feel pretty good about it. 2.718, you good. So let's go to our y equals screen and just type in e to the x. I just want to graph a good old e to the x. So I'm going to do second natural log personally because I want an exponent. So I've got e to the x, and I'm hitting graph. Oh, and then I want to do zoom 6.
What's up,
So e to the x, would you agree your graph, when you did zoom 6 for zoom standard, your graph looks like that? Yeah? Good. So we've got a good old exponentially increasing function. Razzle dazzle. Let's do this. So, you guys, a real quick little backstory. So, after reading all that, I want to give you this exponential growth or decay formula, and it is the following. N equals n sub 0 e to the kt. Let's just say, what the heck are any of those variables referring to, do you think?
T is time.
T is time, I'm down with that. N sub 0. K is that constant or a rate. Very good, bud. If K is negative, do you think that my amount is decreasing or increasing? Decreasing. Good. If my amount is negative, if my K is negative, my amount will be decreasing. If it's positive, it'll be increasing. N sub 0. That starting amount, that initial amount, perfect. Initial, I'll put / starting amount. AMTM rating for amount. What about big N? That, say that again? Final amount, I like that. Final amount, current amount at that time. I agree with that, Roni. Okay, so you guys, referring back to the top of the page, assume that there were this many kilograms of DDT in the environment in 73. They gave you K as negative because that amount is decreasing. Write a function that models the amount of DDT remaining in the environment. I didn't tell you an actual year, so we're going to just say, okay, N is going to equal. What was that initial amount? 1 times 10 to the 9th. What's E? Just leave it. Yep, E is 2.718, but signify that as E. To the K, negative 0.0211 is what they gave us. T. And again, since they didn't ask for a certain amount of time, boom, this is the general formula to find the amount of DDT remaining in the environment at any point in time, just like you had said, Roni. So what if I say, how much DDT is in the environment in 2010? What would I plug in for T?
37.
I heard 3 different answers, but one of them was on point. You guys, if they want in 2010 minus that 1973, because that formula is only good starting in 73. You agree it's 37? So we're going to go plug in a 37 for that T using our calculator. We're going to have a calculator this entire time. 1 times 10 to the 9th, or as Seamus just found out, you could do 1 second sign, or second comma, for the times 10 to the 9th. Second natural log gets you the E to the negative 0.0211 times 37. 458, is that what y'all are getting?
Yeah.
085, oh wait, 458. 085239.4.
Yep.
What if I want to know the amount of DDT in 2030?
Plug in the time.
Same thing, different number. What am I going to do for my time?
20.
Minus 1973 is how many years? Yeah, let's go do that. You guys, do you need to type it all in again, or could we just edit what we had just typed? Guys, just go up and edit it. Delete 3 and put a 5. Is the amount of DDT decreasing? Yeah, thank goodness. You guys, let's go change that. Now let's talk about some money.
What's that called?
Pert. I call this pert. Oh, the Tootsie Roll.
Yes, I'm right.
You guys, do you think pert is very similar to what we just did? It's literally the exact same thing with different variables. And I think that they just changed those variables since we're talking about money now. That's really all it is, but it's all the exact same. So A is going to be which amount, initial or final? It's going to be that end. It's going to be the final amount. Oops. A is going to be that final amount. What are we putting in the P?
Principal.
Yeah, that principal investment. That N sub 0 is that initial amount. So that P is that principal amount, but that's the same as initial. Yeah, you can write initial. R.
Rate.
A rate. You got to make sure that that rate is always given. Do you mind shutting that door, Christian? They're going to give it to you as a... So you guys, they're going to give you a rate typically as a decimal, and you got to make it... I'm sorry, they're going to give it as a percent, and you got to make it a decimal. Meaning, what if I said you're making 6% interest? Is going to be moving that decimal 2 to the left. What if I say you're making 4.5% interest? 0.045%. Very good. What if I'm saying that you're making 0.1%? 0.001 would be the decimal. Oh gosh, why am I putting all these percent signs? 0.001 would be what the decimal that you put in for R here. R you always put in the decimal. Sound good? T. Time in years. Yep. Here we go. Let's make some money, people. Compare the balance. Oh, there's a second formula that I haven't shown you yet. First of all, let's just find out if we invest 10 grand, 6.75% is the interest it's making, 25 years. Let's go find out what compounded continuously would earn us. What are we going to say? 10,000 is my P. E to the 0.0675 times 25. Go see how much money we got at the end of that. So when we calculated that, I got 54,000. Read me the decimal. 48, what?
Wait, no.
54,000. $59. Now, what was give me 3 decimals, just curious. 489. Now, you guys, you agree in math class, we've always been taught that we would round this up to 49 cents, right? Yeah. No bank ever will round that up because that extra penny is going to add up to them when they're rounding up for all of their people. So that dang bank is going to only give you 48 cents. Isn't that ridiculous? Yeah. So compounded continuously, how do you feel about 10 grand turning into 54 grand? Now, granted, it takes 25 years to do it. Did I have to do anything other than give them my 10 grand 25 years ago?
No.
I'll take that. You know what I'm saying? Now, here's my advice to you guys. As soon as you can invest, start small. And my brother, does anyone's brother like to give you advice? And you're like, brother, I'm not here for it. My brother loves to give me advice. This was good advice. He goes, Laura, as soon as you get a paycheck, you guys, when I started teaching, guess what my salary was?
35,000.
Oh, it was 36,000. 36,000 bucks for the year. You had to pay rent, your car payment for my CRV that I still have. That was in 2006. Were y'all alive in 2006?
Yeah. That was when I was born.
There's another formula that I don't know why I didn't make it a fancy, I don't know why I didn't make it a fancy little box, but I need you guys to go put in this other one that is called compound interest. Check this out. I need you guys to write this at the top. Ready, Frederick?
I'm ready.
It's A equals P. 1 plus R divided by N to the NT. And you might be saying, like, why do I have this separate one? Well, you're going to see even in this problem, it said, what if your interest is compounded semi-annually versus continuously? So this N is referring to, N I want you guys to put in, because it's the only new variable. N is the number of times interest is compounded. Oh, I spelled interest wrong. Interest per year. If we've got this new formula for compounded semi-annually, how many times per year would that be? I'm not proud of how I remember semi-annual, but I love me and Nordstrom. And they always have the semi-annual sale, which means twice a year they will have a big sale, and I love that. So semi-annual just means my N will be 2. Let's go see if we'd rather tell the bank compound by interest semi-annually or continuously. Let's see which one makes us more money. If I got 10 grand, I'm still earning 0.0675, which is 6.75%. We're still investing. Oh gosh, new formula. What am I doing? I'm the worst. 10 grand, my bad. There is no E. 1 plus my rate. What's my rate as a decimal?
It's not exponential.
Right. Divided by, what's my N for semi-annually? 2. To the N, oops, my N is 2. To the N, whatever I chose for N down here is going to be the exact same N up there. To the second. How many years we invest in this? 25 years. Go type it in. Let's see if we're going to tell the bank which one we want. Exactly. Yep. So it's going to tell you, look at that one. This one said compounded continuously. Boom. We will use the compounded continuously one. Do we get 52,000? Give me the next numbers.
574.
574.618. What's the bank going to pay you? 61 cents, those weasels. If you guys write 0.62, I'm good with it, okay? I do not care. But just so you know, the bank's going to keep that penny. Okay, that's really all. Oh, yeah. No, I just want to look at one thing real fast. Bakersfield. Anyone ever been to that restaurant in the Short North? Yeah, it's got some good tacos. Bakersfield. No kidding. Which one? Which brother? Jackson. I got you. Okay. You guys, this population used to be modeled by this. Can we stop?
Yeah, what if he didn't just learn that?
You guys, this formula has worked since 1950 to demonstrate the population of Bakersfield. Has the population grown or declined? Could anyone tell me? How do you know without even typing anything in?
Point thing I saw.
Exactly. If that's a positive rate, we're getting more people. So we're going to say grown. And I might even just say K or R, whichever one you want to say, is greater than 0 or positive, whatever helps you understand that. You guys, what was the population in 1950? How'd you know it's 33,430? That's the initial amount, right? What if it's since 1950, what would T be? 0. And what's anything to the 0? So e to the 0 is 1, so we'd be left with 33,430 times 1, which is just 33,430 people. Let's go see how much it's increased, peeps. Let's go see how much. Let's not do 2010. Let's do what it is right now. 2023. Let's be crazy. What do you think T will be then? 73 is the difference between 1950 and 2023. Roger that. 73 years. You guys, let's go type that in. 33,430. E to the 0.0397. T is 73. How many people we got in the Bakersfield?
606,408.4.
Did I write down what you just said correctly?
Yeah.
Okay. Did anyone else get that? All right. This is your homework. What page are we on again? Page 23?
23.
Page 23. Only these 3 questions using these 3 formulas. So on this one, when I say it's decreasing, what's that going to make my K?
Ah, should it be negative?
Yeah.
Because this is time in years, this one is